Establishing key performance indicators for measuring software development processes at a large organization. My name is Sürücü. My co-authors are Bianying, Krüger, Gunter Saake, and Thomas Leich. Large organizations have defined software development processes which usually span various organizational units, for example departments, sub-organizations that collaborate while developing a system. While such an organizational structure can facilitate certain activities, for example eliciting customer requirements is done by specialists in one department, it can also pose challenges, for instance to coordinate development activities, share knowledge, or steer business decisions. In particular, each organizational unit may use own means to monitor their part of the process, hampering comparability and traceability of system and process properties throughout the whole software development process. A helpful means to monitor and steer software development processes are key performance indicators. KPIs, a set of values allowing to analyze and compare an organization's performance regarding specified objectives. However, introducing KPIs in a large organization with distributed development activities and constantly evolving infrastructure is far from trivial. In this paper, we report our experiences of introducing new KPIs at Volkswagen Financial Services, VWFS. VWFS is a large international organization in the financial sector with over 16,000 employees. We found that the existing means to measure are helpful and provide a good intuition about the business trends of each department, defining a reliable basis for managers and specialists of the departments to derive their decisions. However, the existing means and KPIs are too department-specific and do not provide an end-to-end overview of the development process of interest. So we saw potential for improvement concerning 6 criteria. Transparency, intelligibility, coverage, quantification, comparability, and communication. These criteria are heavily related and building on each other. For instance, improving transparency and intelligibility immediately facilitates communication. So these criteria should not be considered in isolation, but tackled together. Our methodology built on developing and evolving a prototype to receive fast feedback and limit the costs of the project before its feasibility could be shown. After training the project leads, we scoped the prototype. Then we designed and customized KPIs to our needs. With the developed prototype, we trained our stakeholders and got feedback. With this insight, we adjusted and extended our prototype. We defined a collection of roughly 25 KPIs that we considered as relevant to measure the qualities throughout our software development processes. We identified 21 of the 25 KPIs from our sources, namely a DevOps workshop, a book, existing tools and metrics established at VWFS. To measure the previously defined criteria in more detail, we defined 3 of these 25 KPIs ourselves and customized one for VWFS. Before developing our prototype, we presented all KPIs to our upper management. To keep the initial effort of the project manageable, the upper management selected the 4 KPIs considered most valuable to be implemented in our first prototype. To test these KPIs, we implemented a semi-automated prototype. With this prototype, we imported data from various sources, for example, databases, tool logs, and processed them into a table. In the end, the step resulted in a list of 11 KPIs we considered relevant for VWFS and a decision towards the intended tooling. We present in our paper an overview of implemented KPIs with the KPI name, definition, goal, and mainly concerning criteria. For instance, delay of requirements is defined as number of days a requirement is behind its deadline. The goal is to identify requirements delays to assess the risk of reduced software quality. The mainly concerned criteria are coverage and comparability. Here we also highlight designed, customized for VWFS or common key performance indicators. To describe and exemplify the KPIs we defined and adopted, we simulated data with the R statistics suite that is within realistic boundaries and resamples real-world characteristics to display examples. We do not show real data from VWFS or its sub-organizations. In this figure, we see a simplified representation of delay of requirements with simulated data. The quality of a software system depends on a reliable requirement specification that has to be finalized at a specific delivery date. Otherwise, the risk of expensive changes and defects increases as delays or later changes can propagate through the whole software development process, impacting the quality negatively. Delay of requirements count the number of days a requirement is overdue and can be used to highlight, among others, those requirements that have been finalized too late or only after their implementation began. Furthermore, to support management and signalize risk and cost-sensitive problems, we can highlight such requirements that we consider to require particularly high effort. This effort can be specified with a threshold. For example, we define more than 70 person days to classify a requirement as costly in this figure. We show a simulated example for delay of requirements in the figure, where red bars highlight requirements that are above the specified effort threshold. The requirements are ordered according to their delay, meaning that those requirements that were delivered in or before their delivery date are represented on the left side. In contrast, all requirements that are overdue are on the right side, starting with requirement 15. So, this overview allows to identify problems in the delivery of requirements and helps to understand the reasons for delays in critical path. Manual test progress and interruptions focuses on measuring the manual test process, also considering whether all resources were available to the tester at the right time. This figure is a simplified representation with simulated data. The blue line represents the target tests, while the green line, the darker line, represents past tests. We can enrich this representation with information about disruptions and use a different representation for real-time monitoring. We can see that not all tests may be defined at the beginning of developing a system, but can be dynamically added until the specification and test suites of the system are fixed. A particularly interesting insight MTPal provides is the identification of plateaus. For example, days 16 to 19, at which no progress has been achieved. Such plateaus can help to monitor the development progress, for example, to identify disruptions that may occur due to system unavailability, to assess the impact of requirements changes. However, the core idea for MTPal is to monitor the development progress overall, namely whether all relevant tests passed. This figure is a simplified representation of priority defects per person day with simulated data, adapted to person months for improved scaling. Blue bars represent the effort in person months for a system, while red bars, darker bars, represent the number of reported defects. The priority defects per person day values are the black dots, representing the ratio between both values. We defined this KPI to relate the number of higher priority defects in a system to its developed efforts in person days. So, this KPI is simply the ratio between both values. As we can see, this KPI does allow to easily compare between different systems and their releases. We use this representation mainly to analyze three aspects. First, we can directly compare between different software engineering methods, for example, by comparing similar systems, for example, in terms of size and staffing, and their priority defects per person day values. Second, we can examine whether the transformation of one system, for example, changing underlying architectures or methods, had positive or negative impact on its development time or quality. Finally, while a value of 0 would be ideal, indicating no higher priority defects at all, we consider priority defects per person day to be a good KPI for our development capabilities. By now, we have elicited our KPIs for over 2 years, and for 6 months we collect all 11 KPIs we show in Table 1 in our paper. Now measuring KPIs is implemented, understood, and accepted across all relevant organizational units. The management uses the KPIs to measure releases and systems, to analyze business operations, and to steer transformations of processes, technologies, as well as methods. For the initially stated criteria, we can summarize the following achievements, building on our own experiences, responses from specialists and management, as well as constant re-evaluations during the quarterly reports. Transparency. We limited the complexity and number of KPIs we report to organizational units and to the management. Based on this, our quarterly reports focus on summarizing the complexity of release occurrences as clear depictions of the developed progress of the system, and other information that the relevant stakeholders consider important for steering. Intelligibility. We achieved a common understanding of our KPIs and how to derive actionable items from them, at least for specialists of the relevant organizational units and the management. So we have improved our ability to monitor and steer our software development processes together with all relevant stakeholders. Coverage. Combining several introduced KPIs allows for a coherent analysis across all organizational boundaries to achieve an end-to-end monitoring of software development processes in their entirety. This improved our capabilities to identify potentials for improving our process and system quality. Quantification. Each of the KPIs we introduced is quantified, providing concrete numbers to specify a system's quality throughout our software development processes. Moreover, we measure process as well as system properties, so we extend our reporting capabilities and the understandability of values as well as actions across all relevant specialists and the management. Comparability. Regularly measuring our software development processes with the same KPIs allows us to compare systems, releases, as well as different software engineering methods and techniques. We see this as a major benefit, helping us to assess the impact of transformations and thus steer the organization based on reliable data. Communication. We hoped that introducing unified and agreed upon KPIs would establish a basis for and thus facilitate internal communication. Considering the regular feedback and discussions, we see that this is clearly the case. We found that the unified communication is a major achievement, avoiding confusions and providing a terminology that is accepted, used, and considered valuable throughout all relevant organizational units. While introducing the KPIs, we found that some steps worked well, while others did not yield the expected results. In the following, we share our experiences, aiming to support other organizations and indicate opportunities for future research. Lesson 1. Large organizations must carefully evaluate to what extent off-the-shelf solutions for key performance indicators suit their demands and can be integrated into their existing infrastructure. While the identified state-of-the-art tool was working as intended, it did not provide the results we aimed to get. For example, the predefined standard DevOps KPIs gave a good impression and vague tendencies of what was happening in our business, but they were not precise enough to detect concrete obstacles and to drive actions from improving the situations. Lesson 2. Focus on a small domain-dependent set of important agreed-upon key performance indicators to establish and evaluate their usage in an organization. We experience it that it is neither productive nor efficient to measure many KPIs simply because they are recommended or readily available. Instead, we highly recommend to perform a detailed domain analysis, discuss with relevant stakeholders to define precise goals in order to select the KPIs that are actually relevant for an organization. Lesson 3. Constantly involve relevant stakeholders in the design and use of key performance indicators, ideally during interactive sessions to communicate benefits, increase acceptance, and improve tooling. Simply introducing KPIs is not useful. They must also be accepted, measured, and understood by all relevant stakeholders. Lesson 4. Consider key performance indicators that are important to the different stakeholders involved to achieve benefits for all organizational units that have to measure and use them. The organizational structure with various units and hierarchies means that we prepare reports for developers and managers alike. To address these different scopes of expertise and working areas, we selected management-oriented but also typical development KPIs. We selected KPIs based on their usability for steering software development processes and for explaining the corresponding decisions to other stakeholders. Lesson 5. Create lightweight prototypes to gain fast feedback on the usability of key performance indicators and to evaluate their value for the organization's businesses. In our experience, this iterative stepwise evolution of our prototype was efficient, constructive, and limited the costs as well as the risks of our project. Lesson 6. Define and maintain a business case comparing the costs and benefits of the established key performance indicators to provide reliable evaluations and not only educated guesses on their value. For example, in order to balance costs and benefits, we decided to rely currently on a semi-automated and not a full automated prototype, but we aim to constantly introduce corresponding changes to automate our prototype further during future transformations. In this paper, we described how we introduced and use KPIs at a large organization in the financial sector. Our experiences show the value of KPIs, but we also highlight potential problems and report recommendations for other organizations. More precisely, we described a lightweight methodology to introduce KPIs allowing for fast feedback. A set of 4 KPIs customized to our needs, they may be relevant for other organizations too. An overview of the criteria we aimed to improve and the impact of our KPIs have had on these, as well as 5 concrete examples. A set of 6 lessons learned which can help other organizations to introduce KPIs related to selecting the required tooling, customizing KPIs, increasing acceptance and usability, involving different stakeholders, evaluating constantly, and providing a business case. We hope that these contributions help practitioners in their endeavors and guide researchers to investigate new research directions. At VWFS, the project is considered a success. We enhance the comparability of releases and processes as well as the comprehensibility and acceptance of our monitoring, which facilitated the steering of actions for improving software quality, which is visible in the improved user feedback. Thank you for your attention.